Hey you guys, for this video I'm actually going to be using this applet. You can see the URL up at the top to kind of explain confidence intervals and confidence levels. So all I told you guys yesterday was that the most common confidence level is 95%. While that's the most common, there are other confidence levels you can use. So here's what I mean by that. A confidence interval is, hey, this number to this number. The confidence level is what percentage are we working with. So 95 is the most common, but the next most common, you can use 99, and you can also use 90. Now, technically, you can do a confidence level that's lower. Like you could do a confidence level of all the way down to 80%, but who wants to be only 80% confident, right? So we're going to talk about what that looks like. So what this applet does, I really like this, this link. So if you want to go to this URL, you can see it typed up right here. It does a really good job kind of visually explaining what a confidence level is. So here's what I'm going to do. I'm going to start with 95% because like I told you guys, that's the most common. And we're going to go with a sample size of 20. So here's what I mean by that. You'll see right here, we're assuming this is the true mean of the population. We don't need an actual number. Like we're just saying kind of in general, the true mean is right here on this green line all the way down. And the population distribution is approximately normal. And the sampling distribution is also approximately normal, but with a smaller standard deviation, okay? So what I'm looking at is, okay, if I take a sample, so from the population, I'm taking a sample of 20 of whatever we're talking about, and I'm going to find the confidence interval. So when I click that, here's what you'll see. You see a bunch of dots. That's my sample of 20. If you count all of these dots, there's 20 dots. So what they did was, okay, this applet took those 20 values basically and said, okay, here is what I think would be my point estimate. And these lines, these bars coming out on either side is like the margin of error. So if I had to say here is like my sample statistic, basically, that's my point estimate. Plus or minus this or this. Now we don't have actual values attached to this just because I want you guys to see how that's working, okay? So here's what this means down here, where it says percent hit, 100%. Basically all that means is if you look, this interval, so here's your point estimate, here's your plus or minus margin of error, notice how the true mean is contained in that value. So I'm gonna hit sample again, okay? True mean is contained. So far, so good. I want to try to get one where it doesn't actually work. Oh, there we go. You see this red one that popped up right here? This particular sample of 20, this was the point estimate, and then plus or minus, here was the margin of error. Notice how the true mean of the population is not in there. And if you come over here, no longer did it say 100% hit, now it's 95% hit. So what a confidence level basically means is if we were to take a sample of 20, over and over and over and over and over again, we're 95% confident. And the reason I say that is it's kind of like if we were to take a sample of 20 over and over again, 95% of those samples would properly estimate the true mean, is kind of the way that works, okay? So if we switch to my notes here, let's go down here, how to interpret a confidence level. So to interpret the confidence level C, say, if we were to select many random samples from a population and construct a C% confidence interval using each sample, C% of those intervals would properly capture the true mean or the true proportion. So that's kind of where that number is coming from. So we're going to explore today, like, why do we pick 95? Like, is there a purpose to that? Did someone just say across the board in science and statistics and, analysis, just, oh yeah, we're going to use 95%? Well, there's kind of a reason for it. I'm kind of skipping around, sorry. I just want to make sure I talked about this. Okay, I want to do this activity really quick. When we go back to the confidence interval, what I'm going to do is sample 25 samples all at the same time. Okay, I'm still going to use 95% confidence interval, a sample size of 20. And I'm going to change just the confidence level and show you guys what happens. So let me switch here. Okay, so I'm going to reset, start from the beginning. I'm going to keep 95%, a sample of 20, and I'm going to hit a sample of 25 over and over and over again. Notice how it says, I've now taken 250 samples. Notice how it says 93% of those 250 samples have properly estimated the mean. okay? So I just keep hitting it over and over and over again. Notice how the more I hit it, it actually starts getting closer to 95. And then there we go. We eventually got up to 95%. So look at these lines, just observe, take a look at the picture. What if I hit reset and I do 99% instead? Okay, I'm going to do 99% and let's take a sample of 25. Do you see how these lines are bigger? What happened is the margin of error has to be bigger. If you want to be more confident in your value, you need to have a larger interval. So you're kind of trading off. You're saying, well, I'm more confident that the mean is actually captured in here, but the interval of those two values is a little bit larger than it would have been. Okay, so what if I hit reset and I go down to 90% and I hit a sample of 25? Now look at those lines. The margin of error on either side is much smaller. So if you're 90% confident, you can actually have a smaller interval that truly estimates the true mean, right? So you're kind of trading off. So what if I went to a sample size that was bigger for those 90%? I hit sample of 25. Notice how right off the bat, only 84% hit, but it's a lower confidence level. So I can kind of keep going. And eventually it gets closer and closer to about 90% is being hit, okay? Look at those margin of errors though, right? So I can either lower my confidence, like I can either raise my confidence interval basically, or change the sample size, and that will affect that margin of error. So, for example, let's do this question together. In the preceding example, and I know it says preceding, we didn't actually do this example, but it gives you all the information anyways. You read about a random sample of 2,253 U.S. adults who were surveyed for the Pew Internet and American Life Project. Based on the survey, the 95% confidence interval for the proportion of all U.S. adults who use Twitter or another service to share updates about themselves or to see updates about others is between 0.167 to 0.213. So remember, they only surveyed this many US adults, and they're using that statistic to estimate with 95% confidence that the true proportion is somewhere between here and here. So explain what would happen to the length of the interval if the confidence level were increased to 99%. So if we wanted to be 99% confident rather than 95, you're going to have to trade off. If you want to be more confident that this interval truly does predict the true proportion, you're going to have a bigger interval, right? So that margin of error is going to have to get larger. The other thing you could do, explain what would happen to the length of the original interval if the sample size were increased to 5,000 instead of this 2,253. Well, then I would actually have a smaller margin of error because I have more people to kind of justify my calculations, basically. Remember, when I'm talking about all this, you guys don't know how to find this yet. I'm going to show you the actual calculations in this unit and where this comes from. Right now, we're just exploring what in the world is a confidence interval in general, okay? All right. Okay, so here is my last slide for today. And let's just kind of talk through it, okay? According to a recent survey by the Pew Research Center, a 95% confidence interval for the proportion of Facebook users who comment on other people's photos at least once a day is 0.31 plus or minus 0.035. Notice how they chose not to use the between this and this. They chose to use point estimate plus or minus the margin of error, right? So you can do confidence intervals either way. So number one, interpret the confidence level. Basically what that means, if I were to take a simple random sample over and over and over again, I would be 95% confident because 95% of those simple random samples would truly estimate the mean between this number plus or minus this value. Okay, so the confidence level is just saying about if we were to do this sample over and over and over again, 95% of those samples would give you a number between here that does truly estimate that true proportion. Okay. Number two, name two things Pew could do to reduce the margin of error. What are the drawbacks of these actions? So, okay, to reduce the margin of error, we could lower the confidence interval. So we could only be maybe 90% confident and be able to give a smaller interval. But see, that the downside with that is that I'm not as confident. right? The other thing we could do is we could get a larger sample size. Well, the drawbacks to that is maybe that costs more money, maybe it's more time consuming. So really that's why if our three most common confidence level percentages are 90%, 95, and 99, that's actually why most of us use 95, is because it's kind of right smack dab in the middle. You're not compromising your margin of error, but you're also not doing too much that's time consuming and to try to get a larger sample, okay? Number 3, the response rate for the survey was only 9%. Ooh, that's not great. That is, Pew was able to obtain responses for 9% of the landline and cell phone numbers that were randomly selected for this sample. Describe how non-response might lead to bias in this survey. Does the stated margin of error account for this bias? Yeah, this margin of error does not count for this bias. This bias is a whole nother problem, right? If only 9% responded, that doesn't make me feel super comfortable with whoever did this survey. Now, having said that, they got their confidence interval and they said, here's what I'm thinking, but 9% is pretty small. I would try to shoot for a larger percentage of adults responding to the survey for sure. All right, you guys, so you do have a homework assignment today. It's due tonight by midnight. So remember, you can either print out the homework assignment and do it on that sheet of paper if you have a printer at home, or you can just do it on a blank sheet of paper. Just label it Unit 7, Homework Number 1. One issue some of you guys told me about last week was when I posted as a Word document, not all the math script shows up. So if you needed like Sigma or something like that, it might not show up when you go to download the homework. I apologize for that. Basically, if I give you a document as a Word document, or if I try to save it as a PDF, it still won't always show all of those because it's kind of like a plug-in math script that I use for Microsoft Word. So basically, my recommendation would be to use the homework that I post. And if it does seem like something's missing or there's a blank really randomly and you're not sure why, go to the answer key because the answer key is scanned. And so it will have all of that data on there, okay? As usual, let me know if you have questions. If you can email me or stop by and see me during office hours and I can try to explain what's going on. So this should be your second official assignment for remote learning. Let me know if you have questions or if I can help in any way. So good luck, you guys.